Welcome back to my YouTube channel. Today's LeetCode DCC question is power of 2. So what question is saying, given an integer n, return true if it is a power of 2, otherwise return false. So there are many ways to solve this question. Let's see few of them. So method 1, so let's write down the binary of a number. So binary of 0 is 0, binary of 1 is 1, binary of 2 is 1 0, binary of 3 is 1 1, binary of 4 is 1 0 0, binary of 5 is 1 0 1, binary of 6 is 1 1 0, binary of 7 is 1 1 1, binary of 8 is 1 0 0. And if we write the power of 2, so this is not a power of 2, this is the exact power of 2. Who is the exact power of 2? 4 is the exact power of 2, and 8 is the exact power of 2. So in this, if we see the numbers which are power of 2, we can see it contains exactly 1 1. So 1 contains exactly 1 1, 2 contains exactly 1 ones, 4 contains exactly 1 ones, 8 contains exactly 1 ones. Number other than the power of 2 does not contain exactly 1 1. In this, we see it contains 0 ones, 3 contains 2 ones, 5 contains 2 ones, 6 contains 2 ones, 7 contains 3 ones. So let's see more example. So suppose 9. 9 is not a power of 2, right? So we can see it contains 2 ones. If we see 10, 10 is also not a power of 2. It contains 2 ones. If we see 16, since 16 is a power of 2, 2 to the power of 4, and if we write the binary of 16, it contains 1 ones. Like 32, it is also a power of 2, 2 to the power of 5. It contains 1, 5 zeros, and it contains only 1 ones. So there is a pattern, right? So by this pattern, we can solve like we will first write down the binary of a number and we will see how many set bits are there. So in this, we have only one set bits. In this, we have one set bits. So in for 9, we have two set bits. So once we will have the number of set bits in a number, in a binary representation of a number, if the set bit count is exact 1, we can declare that number as a power of 2. Else, we will say it is not a power of 2. So let's write down the code here. We will have a counter which will store the number of set bits. And we will do a while loop while the number is greater than 0. And at each iteration, we will see whether the last bit of the number is set or not. So how we can see, say this, by this, we can see if the numbers, if n and 1 means the last set bit is 1, we have to increment the counter. And every time we have to reduce one set bit. That is, we have to do a one right shift. So n right shift 1. Once we are out of the while loop, we will see if the count is not equal to 1. That means the binary representation of the number does not contain exact ones. In that case, we will return false. Else, we will return true. Let's try to run this code. Let's try to submit. So it is accepted. So one more thing we can see. Say we see the question they are saying, could you solve it without loop or recursion? So in this, we can see we have used a loop, right? While loop. So there are other ways also. So let's see one more method. So if we use some mathematics, we can also solve this question. So suppose 10. If we know the logarithm, we can easily solve this question. So suppose if 10, so how the logarithm works? So for any number, if we find out the log value, first we have to give the base value. Suppose log base 10, value 10 is 1. Log base 10, value 100 is 2, right? And other than 10, in between any number between 10 and 100, it will give the values greater than 1 and less than 2. That means the value will be in decimal. Similarly, for the case when the base is 2, so log base 2, if we write 2, it will give 1. Log base 2, if we write 4, it will give 2. For log base 2, number 8, it will give 3. So any number between 2 and 4, it will give a value greater than 1 and less than 2, right? And any number between 4 and 8, it will give a value greater than 2, less than 3. That means the value will be in decimal. The value will be something in point. Here also something will be in point. So we can use this approach. So if the number is perfect, power of 2, we will get the logarithmic value of that number as an integer, exact integer, else we will get a decimal value. So let's try code here. So we can write. And one more thing, if you know the graph of a log, at 0 it is infinity, right? At 0 it is infinity. And for 1, log base 2, anything 1, it is 0. That means for x is equal to 1, the value of y is 0, and after that it increases logarithmically, and for and value less than 1, it is negative, and at 0 the value is infinity. So we will need to give a special check for 0. If we will see, if the value is not equal to 0 and the log value of n, so since we have to see whether if the number is a logarithmic value perfect with power of 2, we will get the number as integer. And if we do a floor value of that number, it will still be the same. But if it is not a logarithmic value, means it is not a power of 2, we will get some decimal. So in this case, the decimal to the floor of the decimal value we will get, suppose if we get 2 point something, and if we do a floor of 2.4, we will get 2, right? And again, if we will compare whether this value is equal to log base 2 of that number, we will get 2.4. So this number and this number will not be same. For example, if we take 3, then logarithmic value of 3 will be 1 point something, right? And if we do a floor of this value, we will get 1. Now we will compare this floor value with the actual logarithmic value of that number. So if this number will be same, that means the number was a power of 2, else it was not a power of 2. So here we will do base 2 of n. That means it matches. In that case, we will return true, else we will return False. Let's try to run the test cases. See, now let's try to submit the question. Yeah, it is accepted. So we have seen two methods. There are many methods. We can use the recursion also to solve this question and other methods. You can try any one of them, but it's better you learn these approaches. Meet you in the next video. Thank you.